Hello, welcome to a new edition of the OpenNebula webinars. My name is Constantino Vázquez. I'm a consultant for C12G Labs. And today I will like to talk a bit about why it's a good idea to use OpenNebula in your VMware infrastructure. So I'm going to give a couple of minutes for attendees to arrive, just in case they are a bit late. And meanwhile, if you have any doubts or questions about the webinar dynamics, just feel free to ask in the chat. So is there anyone having troubles with the audio or with the screen sharing? Can you see my screen? Okay, that's good. Okay, so let's start then. Let's start with a brief overview of the table of contents for this webinar. I'll start with a brief introduction on what's OpenNebula and what's its architecture and why does it adapt to your data center. Then we'll move on to the integration of OpenNebula with your VMware-based infrastructure. So we'll talk a bit about what does OpenNebula offer in terms of integration with your storage, virtual networks, scheduling, virtual machines, and authorization. We'll move on in the to the third section where we'll briefly see the benefits that OpenNebula can bring to your VMware-based infrastructure. We'll talk a bit about the web interfaces available in OpenNebula, like Sandstorm and the self-service. We'll talk a bit about the different APIs that OpenNebula offers in terms of managing the cloud, and some other benefits that you can get by installing OpenNebula to control your VMware infrastructure, like for instance, the ability to define different zones and define virtual data centers, so you can bring the multi-tenancy into your cloud. We also talk a bit about Cloudbursting, so what to do when you run out of capacity in your local infrastructure and you want to outsource some of this computing capacity to some public cloud provider like Amazon EC2. And I'll end up the webinar with a couple of ways to try out an OpenNebula-based cloud through a QuickStart guide or a sandbox prepared for ESX. And we'll end up with a questions and answer round of about 15-20 minutes. Okay, so let's start. Okay. So, what's OpenNebula? Well, OpenNebula is a CMP, it's a cloud management platform. So it basically lets you turn your physical infrastructure into a virtualized environment. So, why do you need OpenNebula? How does it work? Well, it basically it manages a distributed set of physical hypervisors where you can virtualize different aspects of these physical servers. So in the end, it just manages virtual machines distributed across different physical servers. So why is this interesting? Well, if you have maybe a couple of physical servers and you want to run there your virtual machines, then maybe you don't need OpenNebula or, for that matter, any CMP at all. Why? Because, well, you can always keep track of where my VM is running and different other settings. But when that doesn't scale, you need something like a distributed manager like OpenNebula to keep track of where your virtual machines are, or where should I put my virtual machines. So here comes components useful in OpenNebula for the day-to-day cloud operation, like for instance the monitoring and scheduling. There's also when the number of physical servers increases, the answer to the question how do I provision a new VM becomes complicated. So that's where it comes into play the image management and contextualization of OpenNebula. Also, if I want to offer the power of my cloud infrastructure to other users, there's always the question of who have access to my cloud and what resources inside that cloud. Then you will need something of user and role management. Also, the question of how do I create a new disk may become complicated with different configurations in different servers. So OpenNebula tries to abstract that through the storage mechanism. Also, the question of networking. How do I set up networking? How do I create a multi-tier services interlinked between the different VMs that compose the service? Well, OpenNebula can help you with that with the network management and the offering of VLANs. It also can answer the question of how can I manage a distributed infrastructure. Well, with a couple of servers, you can manage it yourself. With something bigger, you may need a set of interfaces and APIs, like OpenNebula's command line interface or the OpenNebula Cloud API to manage this distributed infrastructure. Oops, sorry. So also, OpenNebula lets you use different kind of hypervisors. So also the question of can I use a certain hypervisor? Well, OpenNebula supports a broad number of them, so probably the answer is yes. So all of these components put together creates a uniform management layer that orchestrates multiple technologies in order to achieve private, hybrid, or public cloud. So all of these technologies, all these components is what we call OpenNebula. Okay, this is a very brief overview of the architecture of OpenNebula. So as you can see, the main component is what we call the OpenNebula core. It's a robust and relatively small C++ daemon, which works on abstractions. So it basically has an abstraction of a physical host, an abstraction of a virtual machine, of an abstraction of the different components, both physical and virtual, that compose a cloud. So how does this OpenNebula core actually gets its actions into the underlying infrastructure done? Well, it does it through what we call the drivers or plugins. So OpenNebula manages different components, like the monetization component that will basically extract information for a physical server. Also the virtualization component, which is the one that carries out the operations that involve the hypervisor, like the creation of a virtual machine or the suspension of a virtual machine and so on. We also have, OpenNebula also has drivers for storage and images. So images being catalogs of images. So for instance, you can have different catalogs for different groups of users of images. So the drivers take care of the inclusion of new images into the catalogs. And then you have the storage drivers, which are the ones that take the images from the catalog and moves them into the virtualization node to form a virtual machine. So drivers for networking to take care of the physical networking and enabling the virtual networking, and also drivers for authorization, which basically provide different mechanisms to authenticate and authorize the users. Okay, and it's also worth mentioning the database, which provides persistency to the OpenNebula daemon. On top of this OpenNebula core, we also find different layers. Oops. Sorry again. We also find different layers. For instance, all the upper layers communicates with the OpenNebula core with an XML RPC API. This is the most rich API offered by OpenNebula, but then gets abstracted away by the OpenNebula Cloud API, which provides binding for Ruby and for Java. So all the components that interact with OpenNebula uses this OpenNebula Cloud API, or OCA, as we call it. So you have like the command line interface, which is a small set of Unix-like commands to manage your cloud. Talking through OCI. Also, all the graphical interfaces, the web interfaces like Sandstone, also the self-service. Also talk with the core through these Ruby bindings of the OpenNebula Cloud API, and also the cloud service, meaning the cloud APIs, the public cloud APIs that OpenNebula implements, like for instance a subset of the Amazon EC2 interface, and also the OCCI standard, which is the OGF initiative to create a standardized interface to manage clouds. It's also worth mentioning that the scheduler is a separate process that extracts information from the OpenNebula core and tells it how to place the VMs in which physical hosts. Okay, so this plugin-oriented architecture is interesting for a CMP that tries to integrate with an existing data center. So we know that not two data centers are the same. So there are different components, a whole ecosystem of components where OpenNebula needs to fit in. So we just didn't want to design a solution for a specific type of data center, but for the broadest number of data centers. So that's why OpenNebula features a plugin architecture. So if you want to handle a different hypervisor, it's just a matter of writing new virtualization drivers instead of having to redesign maybe a part of the core or something even more difficult. Okay, so what does OpenNebula offer in terms of integration in your infrastructure? Well, we're going to talk about 5 different components. We are going to talk about the storage and how OpenNebula can take the most out of your VMware-based infrastructure by managing the storage. Also, how does OpenNebula deal with the virtual networking offered by VMware hypervisors? We'll talk a bit about the scheduling, how OpenNebula performs in scheduling and what can it offer to your VMware-based infrastructure. Also, what OpenNebula can do about managing virtual machines, and how can OpenNebula integrate with your existing authorization tools to offer a user management layer on your VMware based infrastructure. Okay, so in terms of storage, OpenNebula can compartmentalize your infrastructure in different clusters. So we see here an OpenNebula frontend, which is basically managing 3 different clusters: cluster A, cluster B1, and cluster B2. So we see here that these clusters have different physical servers that are getting their images from different places. So cluster A, it's taking the images from data store 1, and cluster B and cluster B2 are taking their images from data store 2. While OpenNebula controls all the physical servers and the data stores from a single location. So what are the benefits from this? Well, first, the most clear benefit is the ability to balance input-output operations across different clusters. So you may want to have your development cluster, call them B1 and B2, where they use just one data store for nurturing both clusters. But you may want to have cluster A, which is a production cluster, and you want it to be as robust and quick as possible. So you devote whole data store to it. So this data store can be served by a really big SAN cabinet, or it can be a NAS dedicated server, or it can be just a single server for a pilot cloud. There's multiple choices, and OpenNebula can handle them simultaneously in the same infrastructure. Okay, so in terms of the storage that can be managed through OpenNebula in a VMware-based infrastructure, we find that we have 3 possible setups with OpenNebula. We can go for an NFS-based storage model, where the VMware ESX will mount the data stores remotely using a distributed file system like NFS. And OpenNebula will use these data stores to stage the images into the ESX hypervisors. The advantage of having the same data store mounted by different ESX is that you can migrate the virtual machines between them, and also it allows OpenNebula to achieve a quick deployment of new virtual machines, because the images are already accessible by ESX. So that's the NFS setup. You can go for a SSH setup, where the OpenNebula frontend will stage the images into the specific ESX hypervisors, and then the deployment time will increase a little bit. So a new VM will take a bit more to launch, but then the advantages would be to have the virtual machine running locally in a local data store, just available for that ESX. So you are losing vMotion capabilities, but you are gaining the better performance that gives a virtual machine to have it running locally instead of have it running on top of an NFS partition. And there's a third possibility that just came out in the latest OpenNebula 3.8 twinjet, and it's the ability to manage BMFS volumes. So now we can have a setup that is depicted here in this picture, which basically allows you to have an OpenNebula frontend with no access to any data store, no need to mount here any data store, but using VMware specific APIs, it can control operations on the ESX to be able to stage images from a remote BMFS server, like a SAN server with BMFS partitions. So in this way, you can have either an external BMFS server, or you can have these data stores mount locally with the increase of performance. The advantages of having BMFS partitions are better performance, and also much better locking management of the disks that compose a virtual machine. Okay, moving on over on virtual networks, on how you can manage your virtual networks in your infrastructure using OpenNebula. We see that we have two choices here. We can either use the predefined port groups, so all the machines will live in the same port group in the ESX hypervisor. So this is very easy to configure, and it's just suitable for pilot deployments because different VMs in different in different virtual networks, like these two machines and this machine, will still have be in the same port group, so they could sniff on each other, right? They are fully isolated. For more production-ready clouds, you need to go for a dynamic networking, where OpenNebula will create different port groups for different virtual networks. So a service that is running in a port group will be completely isolated from a service running on a different port group. So two virtual networks will be effectively completely isolated. Okay, talking a bit about scheduling. So what can OpenNebula offer in your VMware-based infrastructure in terms of scheduling? Well, OpenNebula bases its scheduling mechanism in a matchmaking algorithm controlled by rank and requirements. So we see here a virtual machine. We see here 4 virtual machines, right? So we see here that the first virtual machine has 2 physical servers as candidates to be deployed into. So how does the scheduler select these 2 virtual machines? Well, it uses the virtual machine's requirements expression. So when you define a virtual machine, you set the requirement field, and you say, okay, I want just physical servers with over 40 gigs of hard drive, or maybe virtual servers with more than 16 gigs of RAM. So OpenNebula will select the 2 hosts, in this case, that are suitable to hold this virtual machine. If we move on to virtual machine 2, we see that requirements have filtered out another 3 different hosts because the requirements were different. We see here that there's 2 black hosts, physical hosts, and a gray one. So why these 2 ones were placed first? It's because of the other attribute of the virtual machines that you can set. It's the rank attribute. So once the requirements have filtered out the hosts, then the hosts are ordered through the rank expression. It can be, for instance, CPU speed. So I want this virtual machine to be able to be deployed in these 3 hosts, but between these 3 hosts, please pick the one with more CPU speed, for instance, and so on for the rest of virtual machines. So this matchmaking algorithm based on requirements and rank, it's at the same time easy but very powerful to implement different types of scheduling policies, like for instance stripping policy or affinity, or well, you name it. There's a lot of different policies that can be built using this matchmaking algorithm. So in terms of operations on virtual machines, OpenNebula can offer you a full management of the VM lifecycle on the virtual machines running on your ESX hypervisors. So it allows you to do all the low-level, well, not low-level, but basic VM operations like submit, suspend, stop, resume, deleted, cancel, and so on. And in these virtual machines, it offers the full feature support of OpenNebula. So you can have virtual machines running on your ESX hypervisors and contextualize them. So passing them information from from the outside before the VM is boot. You can access through VNC these virtual machines, even through the Samsung web interface. You can create volatile disks, many other things that are basically the feature set of OpenNebula. You can achieve that by letting OpenNebula manage your ESX farm. And it kind of removes the dependency of the VMware ESX-based infrastructures on vCenter. It's not needed just for the having vMotion capabilities. So if you are interested in doing live migrations, you will still need a vCenter, but it really won't affect any other operations apart from live migration. Okay, so also OpenNebula through the authorization plugins lets you manage your user base with different mechanisms. You can rely on the internal users database of OpenNebula, and you can plug it, the OpenNebula service, into different authorization mechanisms, like for instance LDAP or Active Directory, or you can base the authentication in technology like SSH keys or X509 certificates. Sorry. Okay, so what are the benefits of letting OpenNebula drive your VMware-based infrastructure? You're gonna see the two web interfaces that will allow you to manage your infrastructure using OpenNebula, mainly the Sandstone and the SelfService Portal. We'll take a look at the APIs offered by OpenNebula that will let you basically manage different APIs and so run away from the vendor lock-in. We'll briefly show the advantages of defining different zones and different virtual data centers so you can achieve a multi-tenancy in your cloud, and also the ability to do some cloud bursting. So when your local infrastructure is saturated and you want to offer more computational power to your users or to your services, then you can outsource your computational needs to a public cloud server, like for instance Amazon EC2. Okay, so this is a screenshot of the dashboard of Sandstone, and here you can see Sandstone as an administration tool to your infrastructure. So you can see here that you will be able to manage the users and the groups that will be able to use your cloud, and also define access control lists. So these users have limited access to the physical and also the virtual resources. You will be able to manage your virtual resources, like your virtual machines, your virtual machine templates, also the images that conform these virtual machines, and you'll be able to group your physical hosts in clusters, to define new data stores to store the images, and also it will let you create and let other people use predefined virtual networks. Also, access to a marketplace. This is a public service offered by C12E Labs, where you have some welding images that you can import into your local infrastructure to create new virtual machines in a really quick way. Moving on to the self-service portal. This is a simple interface that can be used to offer external users. So this will offer just an interface to your virtual resources. So people here will be abstracted away from the underlying layout of your infrastructure and will be given a more abstract view, public cloud view, if you would like for instance the Amazon EC2. So it will let your users to manage their compute, storage, and network resources, and that should be enough for public cloud users to take advantage of your infrastructure without knowing too much details. Okay, in terms of APIs, OpenNebula offers different access mechanisms to your cloud. It offers command line interface for sysadmin like guys who likes to use shell and want to use Unix-like commands to manage the cloud, and also through the Sandstone web interface we just saw. There's also the self-service interface for external cloud users, which is based on the OCCI standard. So also any OCCI compliant tool will be able to make use of your OpenNebula cloud. And also there's a subset of the EC2 de facto standard API to access public cloud. So you will be able to use all the tools that are all the broad ecosystem of tools that are constructed on top of the Amazon EC2 cloud. So you will be able to use them to take the most out of your private cloud. So for instance, you will be able to use the Hybrid Fox extension for Firefox to manage your local infrastructure. It's also worth noting that through the XML RPC interface, you will be able to develop your own custom scripts to automate some daily tasks. Okay, so a VMware-based infrastructure can be used to create virtual data centers using OpenNebula. So say you have an OpenNebula zone, which is basically an OpenNebula instance. So this zone can be further compartmentalized into different clusters. For instance, this will be the cluster of fast deploying VMs. And this will be the cluster of VMs that are deploying in local hard disks. So the IO performance will be better. And you have a centralized way to manage different OpenNebula instances. On top of this, you can create virtual data centers inside these clusters. So you may want to have a group of users, say your developers, to make use of a virtual data center that's basically giving access to 4 physical servers in this case. So all the mechanisms to compartmentalize clusters and to group clusters into different zones are offered by the OZones component, which also features a separate command line interface and a separate graphical interface to have a centralized way to manage different OpenNebula zones. Okay, so Cloudbursting, how does it work? Well, basically, OpenNebula can manage your local physical infrastructure based in VMware, and to construct a virtual infrastructure on top of that. This virtual infrastructure may grow into a public cloud provider. So this virtual infrastructure has to carry out work that is not sufficiently satisfied by the local physical infrastructure. OpenNebula can diverge or outsource some of the virtual machines to a public cloud provider, like for instance Amazon EC2, to create a bigger virtual infrastructure than that it's achievable using your local resources. So the motto here is don't ever run out of capacity. Outsource your virtual machines to some public cloud. Obviously, you will have to pay, but your services, your virtualized service won't suffer. Okay, so we're approaching the end of the webinar. I would like to state 2 ways to quickly try out OpenNebula in your local infrastructure. The first one is a quick start guide that is available through this URL. It's basically will show you step by step how to create a virtual machine, or well, not create a virtual machine, but how to install OpenNebula on a CentOS physical server or virtual machine to be used as the cloud front end. And then how to configure SSX hypervisor to be able to run virtual machines controlled by the OpenNebula front end. So this guide is available at this URL, and it's basically a process that takes about half an hour, but you will have a fully functional cloud. Maybe it's a pilot cloud, but it can be easily extendable to achieve a production cloud. If you have even less time than half an hour to try out OpenNebula, you can download OpenNebula 3.8 ESX sandbox. It's basically a virtual machine with OpenNebula pre-installed. So if you have a VMware ESX laying around, you can launch this virtual machine in this ESX server, and it features a complete cloud using QEMU emulation. It will give you the experience of running a cloud inside a single virtual machine. And that's the end of the webinar today. I mean, I will be happy to answer any question now. So if you have any questions, please, now it's the time. Take the opportunity to comment that we have reached 5 years in the OpenNebula project, and we are very, very happy to have come such a long way since 5 years ago, and we hope that that you find OpenNebula useful to manage your resources. Oops. Okay, some questions now. First one, Danilo Ngami is asking, is OpenNebula able to manage a VM on a Red Hat Enterprise Visualization cluster? Well, the answer here, in short, is that there's no official supported way to run an enterprise virtualization Red Hat based cluster, but there's some third-party components to achieve integration with, I think it's OBERT. So does the TwinJet feature cost extra? This is asked by Benjamin Thott. I would like to clarify that OpenNebula TwinJet is just the code name for OpenNebula 3.8, and no, it doesn't cost extra. It's just the standard feature set of OpenNebula, includes the BMFS drivers. Okay, some more questions. Udo Jorens, sorry if I don't pronounce your name correctly, asks if it's possible to manage other virtualization technologies besides VMware, and the answer is absolutely. OpenNebula can manage both KVM-based infrastructures and also sham-based infrastructures. In fact, it can manage the three of them simultaneously. So you can have an OpenNebula cloud based on maybe one cluster with VMware hypervisors, another cluster with Xen hypervisors, and another cluster with KVM hypervisors. And OpenNebula will give an homogeneous view of both, I mean, all the three technologies. So Benjamin, it's asking if the Hyper-V technology will be supported in the future, and the answer is yes. We are working on Hyper-V prototypes. In fact, I think we have some early prototypes disclosed in the ecosystem. So if you go to the OpenNebula ecosystem webpage, you will be able to maybe take a look at the Hyper-V drivers, and we'll support them in the midterm, I guess, not the short term, but in something like a few months, probably will be a Hyper-V supporting OpenNebula. So Danilo is asking where can he find the information in third-party software. Yes, if you go to sorry, you go to the OpenNebula web page, and you go to, I think it's software, and you go to the ecosystem. You'll find here a list of third-party developed components that are compatible or are ready to work with OpenNebula. So the URL would be opennebula.org/software:/ecosystem. That's okay. Okay, do you have any other questions or comments on the webinar, or ideas for future webinars, or whatever it may cross your mind? Still have some few minutes left. Okay then, so, oh, sorry. Okay, so Udo Jorens is asking what the main difference between enterprise and the open version. So there are basically no difference in terms of the feature set. The enterprise version offers some high-level tools like service management tools, and the main difference is the frequency of the bug fixes and also the long-term support. So, for instance, if a bug is discovered in the community version, it will take a while until a new version is released. But in the enterprise version, if a bug is discovered, then an asynchronous release will be offered. So yeah, you are. I'm more than happy to accept requests on LinkedIn. Benjamin is asking if a life cycle is included in the management. Not sure if I understand the question, but in terms of virtual machine life cycle, um, I mean the life cycle is rich, and it can be controlled completely using the XML RPC interface, all the tools that OpenNebula offers to that respect. If we are talking about service management, the community version doesn't offer service management lifecycle, but the enterprise version does. By service, I mean an interconnected set of VMs. So with AppFlow, I think it's called, you can control a service like a compound of virtual machines. So you can stop them altogether, or stop or deleting them, for instance. Whereas in the community version, you will need to go one by one. So Benjamin is asking if there are linked clones supported. I'm guessing you are talking about VMware linked clones. The answer is no at the moment, but We are working in that feature for the upcoming 4.0 release, which will be due in early January. So Danilo is asking if there's a feature to measure and billing the resources used by the customer. So the answer here is that OpenNebula out of the box provides accounting. So you can query OpenNebula on things like how many CPU hours have this user used in the last month, or how many virtual machines with how many RAM this user launched in the past week. But there's no out of the box integration with any billing software. But due to the flexible and modular architecture of OpenNebula, it is really easy to integrate any billing platform like WHCMS or um, uh, well, any other billing platform can be um, easily integrated with the accounting module of OpenNebula. Yes, definitely. That's the idea. I mean, if OpenNebula is able to store that information and offer them in different formats, then it shouldn't be an issue to build the user after that. So Danilo is asking if may he also assign a resource pack usable from the users. I'm not quite sure what you mean by this. If you mean restrict um, users to access just a subset of the available resources, the answer is yes. Through ACLs, you can control that, or even through virtual data centers, you can restrict what users have access to. Okay, Danilo further explained that he mean if you can restrict a user or a group to use 10 cores or 100 gigabytes of storage. Yes, the answer is yes. You can define quotas for users or groups. So you can define a group that we only have access to use, yeah, exactly, something like 100 gig of RAM through the course of a week, or just store images that weigh up to 1 terabyte or things like that. So quotas are embedded in the OpenNebula core, and they are quite flexible. Okay, so appears to be no more questions. I would like to thank you, all of you, for coming to this webinar, and just say that I'm available for through email or LinkedIn or whatever is your favorite mechanism to let me know your feedback on this particular webinar or future webinars you would like to have addressed, or any particular doubts on OpenNebula. I'll be more than happy to answer them. So you can reach me through my email that I can put here. It's sinova@opennebula.org. So I'll be more than happy to answer any OpenNebula related doubts through this email. So thanks everyone for coming. I'll see you in the next webinar. Bye.